when we had that interpolating polynomial, and which was this particular value. Okay, so today we'll do the parallel thing, and we will write the formula for Newton backward difference method, and then we'll do an example also how we can evaluate the interpolating polynomial using Newton backward difference method. And then we will also try to understand, because both the methods are doing the same job, so which method is appropriate depending on a particular situation, so that we can choose if a certain thing is asked from the data, so whether we should use Newton forward difference method or Newton backward difference method. We will also have a discussion on this. Okay. So let me start with the Newton backward difference, Newton Gregory. Can you see the screen?
Yes, sir.
Yes.
Okay, fine. All right, Newton Gregory. Backward difference formula. Backward difference formula. So basically what will happen, in forward difference formula we were using the forward differences, in the backward difference we'll use the backward differences. Okay, so again the same thing, suppose n points are given to us and we are trying to get a polynomial, so this will be equal to, I'm directly writing the formula, fx equals to fxn. So these are the points given to us, x naught comma fx naught till xn comma fx. These are the points given to us. Okay, so the formula will be fx equals to f of x, f of xn plus backward difference u into backward difference of f at xn plus u into u plus 1 divided by factorial 2 into second backward difference of f at xn. In this way it will keep on going till u into u plus 1, u plus n minus 1 divided by factorial n, and nth backward difference of f at xn. So this is the formula where we already know this u is nothing but u equals to x minus xn divided by h. Okay, or if we write in a xn x minus xn equals to hu. This implies xn equals to x minus hu. So this will be the value of xn or the value of u. So if you carefully observe what is the difference between forward and backward. In the forward difference formula, everything we did and it started with the very first data of given tabular data. But in the backward difference, what is happening? It is starting with the very last entry of the tabular data, and there is a difference between the value of u as well. In forward difference, it was x minus x naught divided by h, and in backward difference, it is x minus xn divided by h. Okay, so let me take the same example, and we will try to get an interpolating polynomial with the help of this Newton backward difference formula. Okay, so suppose the same data is with us. Suppose this is x, this is example. Suppose we have x which is at 0.1, 0.2, 0.3, 0.4 and 0.5. Okay, and its fx values are, it is given 1.40, 1.56, 1.76, 2.00 and 2.28. So I have already told you there is no difference between when you create the table. The procedure for creating the table is same. The only thing is how we are picking the data that makes a difference, whether we are using the Newton forward difference formula or the backward difference formula. So quickly, if I write its difference table, so it is going to be 1.56 minus 1.40, that is 0.16, 0.16, 0.20, 0.24 and 0.28. And then next difference is going to be 0.04, 0.04, 0.04, and this is going to be 0.0, 0.0, and this is going to be 0.0. So this is the difference table. Okay, so what would be the values of, because when we are intending to use the Newton backward difference formula, so what we needed the backward difference x5. I'm writing it according to this particular case, but in general this is backward difference of f at xn. Since n is 5, so that is why I am writing a backward difference of f at x5. And similarly, this value will be second backward difference of f at x5, and this value will be third backward difference of f at x5, and this value will be the fourth backward difference of f at x5. Okay, so we can use this formula to get the polynomial. So in this particular case, what would be the formula? The formula will be f of x equal to f of x5 plus u, will later on see what would be the value of u into first backward difference of f at x5 plus u into u plus 1 upon factorial 2 second backward difference of f at x5 plus u into u plus 1 into u plus 2 divided by factorial 3 into third backward difference of f at x5 plus u into u plus 1 into u plus 2 into u plus 3 divided by factorial 4 into fourth backward difference of f at x5. Let me rewrite this. Fourth backward difference of f at x5. So this is first backward difference, this is second backward difference, this is third backward difference, this is fourth backward difference. Okay, so we can put every value here. So this is going to be f of x equal to f of x5, that is this value is f of x5 2.28 plus u into first backward difference 0.28, so 0.28 plus u into u plus 1 into second backward difference, it is 0.04. Okay, plus you see third backward difference and fourth backward difference is 0 in the table, so this value and this value will be 0, so plus 0 plus 0. So ultimately what we got f of x equals to 2.28 plus 0.28 into u plus 0.04 into u plus 1. Okay, this is fine. So we can convert this into x. So for converting this, we have this formula x minus xn, that is x minus x5 equal to h. H is 0.1, interval of differencing 0.1. Yes, बताइए.
सर ये वहाँ पर सर फैक्टोरियल 2 भी आएगा.
ओके सॉरी ये u plus 1 में ना, हाँ, डिवाइडेड बाय फैक्टोरियल 2 डिवाइडेड बाय फैक्टोरियल 2. ठीक है, थैंक यू. अब ठीक है.
यस सर.
Okay, ठीक, thank you. So x minus x5, I'm using this formula x minus xn equals to hu. So x minus x5 equals to 0.1 into u. So u will be nothing but x minus, and what is x5? x5 is 0.5. 0.5 divided by 0.1. Okay, so if you put these values here, this is going to be f of x equal to 2.28 plus 0.28 into x minus 0.5 divided by 0.1 plus this will be 0.02, I am removing factorial, into u, that is x minus 0.5 into u plus 1. U plus 1, so this value will be u, that is x minus 0.5, this is divided by 0.1, x minus 0.5, 0.5, this is divided by 0.1, 0.5 upon 0.1 plus 1. Okay, so this will give you the polynomial. If you simplify it, this is going to give you this value, 2x square plus x plus 1.28. You should verify it. 2x square plus x plus 1.28. Okay. So luckily, if you recheck with the case when we did use the same data and design the interpolating polynomial using forward difference method, we got the same polynomial. This is just a coincidence that we got this polynomial. In general, both the polynomials may be different. Okay, so these were the scenarios and methods how you can write the interpolating polynomial using forward difference method and backward difference method. Now the question arises when one should use to for when one should go for forward difference method and what would be the scenario when one should use Newton's backward difference method. The thing is very clear because since we are trying to get the interpolating polynomial, so it means we are trying to get the value of certain entity, for example value of fx in this particular scenario where value is unknown to us. Okay, for example in this exercise it would have been asked find the value of fx at 0.45. Okay, because at 0.45 the data is missing, we don't have the data, but once we have the interpolating polynomial then we can have its value. So depending on where the value is asked, for example if it is asked to get the value of f at 0.45 and where that 0.45 is lying, it is lying in the lower part of the data. So in that case we should use the Newton backward difference formula. On the other hand, if suppose it is asked to find the value of f near x equals to 0.15 or at x equals to 0.15, so it is in the upper part of the data, so in that case we can use the Newton forward difference method. You can use either one of them to get the value of fx at any point, but if we have the idea that the data is lying in the upper half or the lower half, in that case if you use the forward difference and backward difference accordingly, then the amount of error would be less. Okay, amount of error would be less, so it will be more accurate. How we can calculate that error, we will see when we will develop a more general formula for equidistant tabular data as well. Then we will see how we can calculate the error. But as far as how we should choose between Newton forward difference and backward difference, it totally depends where the missing data has been asked. If it is asked in the upper half of the given tabular data, we should use the Newton forward difference. If it has been asked to get the data from the lower half, you should use the Newton backward difference. Now, if suppose the data has been asked from the middle portion, for example 0.25, in that case you can use either one of them, Newton backward or forward. But a specific method is also defined in this course, that is called the central difference method. So central difference method can also be used to get the values if we are looking for the missing value in the middle of the data. So that central difference I am skipping for the moment, and I'll see if we can revisit it again. But depending on in which lower half the data is asked, you can use either forward difference or backward difference. Central difference, if the time allows, then we can revisit it. But for central missing values, we also have a specific method that is called a central difference method, which we are skipping for the time. अब बताइए इसमें क्या समझ में नहीं आया?
सर यहाँ पे हमारे जो नंबर ऑफ जीरोस थे वो सेम आ रहे थे फॉरवर्ड और डिफरेंस मेथड के जो हमारे थे, बट अगर नंबर ऑफ जीरोस डिफरेंट हो गए तो फिर जिसमें नंबर ऑफ जीरोस कम है उसका पॉलिनोमियल ज्यादा डिग्री का आ जाएगा। तो सर हम कह सकते हैं पॉलिनोमियल डिग्री अगर ज्यादा होगी तो एक्यूरेसी भी ज्यादा मिलेगी।
पॉलिनोमियल की डिग्री आपकी ज्यादा होगी, नो डाउट एक्यूरेसी ज्यादा मिलेगी, बट इट हैज नो इशू विद द यूज ऑफ फॉरवर्ड एंड बैकवर्ड। जैसे फॉर एग्जांपल इसी टेबुलर डेटा में सपोज ये जो वैल्यूज है, ये वैल्यू और ये वैल्यू, अगर ये नॉन जीरो होते तो आपको क्या मिलता, आपको क्वाड्रेटिक पॉलिनोमियल की जगह फोर्थ डिग्री की पॉलिनोमियल मिल जाती। ओके, तो उस केस में आपका रिजल्ट और एक्यूरेट होता अगर आप x की वैल्यूज को अपर हाफ में ही इवेल्युएट कर रहे हो, बट एट द सेम टाइम सपोज यहां पे तो ये नॉन जीरो रहता है, बट अगर आप बैकवर्ड डिफरेंस लेते हो, सपोज ये जीरो मिलता है, तो यू मे गेट अ लोअर डिग्री पॉलिनोमियल। बट स्टिल अगर आपको डेटा मिसिंग डेटा लोअर हाफ में पूछा है, then you should choose the backward difference method, because in that case also, even being a lower degree polynomial, the accuracy of the interpolation is going to be much better than the forward difference. So no doubt यहाँ पे incidentally these entries became zero, but जितनी higher degree की polynomial होगी, no doubt your accuracy would be that much of high.
ओके सर।
ओके, एक्चुअली यहाँ जीरो से ज्यादा कंसर्न नहीं है हमारा। जीरो तो क्यों हमें मिल रहा है, बिकॉज ऑफ द टाइप ऑफ डेटा वी हैव बीन गिवन। द ओनली कंसर्न इज कि हाउ मेनी नॉन जीरो कोफिशिएंट्स वी शुड गेट। ओके, जितना ज्यादा नॉन जीरो कोफिशिएंट मिलेगा, और नॉन जीरो कोफिशिएंट आपको ज्यादा कैसे मिलेगा, जितना ज्यादा डेटा आपको गिवन होगा। कोई पर्टिकुलर वैल्यूज जीरो हो जा रहे हैं, वो दैट इज अ केस ऑफ कि पर्टिकुलर डेटा के कारण जीरो हो रहे हैं। बट आपको हायर डिग्री पॉलिनोमियल का जो जनरल फ्रेमवर्क है वो कैसे मिलेगा, वो उससे मिलेगा कि जितना ज्यादा डेटा आपके पास होगा उतनी हायर डिग्री की पॉलिनोमियल मिलेगी आपको। सो द मोर डेटा इज विद अस, वी कैन हैव द मोर बेटर इंटरपोलेशन एंड बेटर एक्यूरेसी। उसमें इंडिविजुअली कोई जीरो हो रहा है, दैट इज अ वेरी पर्टिकुलर केस, बट इफ यू इन जनरल आर इंटरेस्टेड टू नो कि इन व्हाट circumstances we can have a more accurate result, so that is the key, that you should have more data. If you have more data, then naturally the interpolating polynomial is going to be a higher degree polynomial and your error will be less. Okay,
ओके सर।
okay, all right. So these two methods we learn, but they are specifically designed in the case when data is equidistant, means the interval of differencing, that is small h, it is fixed. But now there may be a situation that the given tabular data is not equidistant. In that case we do have methods. We are going to focus one of them, and it is called the Newton's divided difference method. Okay, so let's see how it works. It will also develop an interpolating polynomial, and it can be applicable for both equidistant and distant data. So it's our choice whether we wish to use this one or the one which we studied. But these two methods which we just finished now, they are applicable only in the case when the data is equidistant. Okay, so let me write the we'll study two methods. One is Newton's divided difference formula, interpolating polynomial, for general data. Here general data we mean that it may be equidistant, or it may be non-equally spaced. Okay, so in this case we will learn two methods. The one of them is Lagrange interpolation method. Lagrange interpolation method. And another one is Newton's divided difference method. Newton's divided difference method. Okay, so first let's deal with this Lagrange interpolation, then we'll focus on Newton's divided difference method. Okay, so suppose we have this type of data with us. So first we are going to do this one, Lagrange interpolation method. So let x naught comma f naught. F naught means f of x naught. X1 comma f1. F1 stands for f of x1. Xn comma fn are the given data points. Are the given data points with arbitrarily spaced xj. Means it's not necessary that x1 minus x naught and x2 minus x1 is same. So that is, we have declared that this xj is arbitrarily spaced. So with the help of this Lagrange interpolation method, we will define some multipliers, and then we can get linear, quadratic, cubic, and higher degree polynomials. Okay, so what basically Lagrange defined that it has defined some coefficients like this: L naught x, which is nothing but x minus x1 divided by x naught minus x1. L1x x minus x naught divided by x1 minus x. Okay, so if we try to get the linear interpolation, means we wanted to interpolate the data using the linear polynomial. So in that case, this Lagrange linear interpolation this was defined like this: P1 of x. P1 means we are getting a polynomial of degree 1. P2 means polynomial of degree 2. It is L naught x into f naught plus L1x into f1. Okay, so basically it will be nothing but L naught x की वैल्यू हम पुट कर सकते हैं वो जो डिफाइन किए यहाँ पे. This is x minus x1 divided by x naught minus x1 into f naught. F naught is the value of f at x naught plus L1, that is x minus x naught divided by x1 minus x naught into f1. So everything is known here. We can put the values of x naught, x1, f1 and f naught. It will give you a polynomial of a degree 1. So basically it is nothing but a line joining passing through the point x naught, f naught, comma x1 into f1. So that is why we are mentioning it as a linear polynomial. So this p1x is nothing but the line joining the point x naught, f naught and x1, f1. Similarly, we can enhance this idea and go for the quadratic interpolation, Lagrange quadratic interpolation. Quadratic interpolation. So in that case, what we'll get? We'll get the value of p2x, means the polynomial of degree 2, and this is how it will be defined. Now we'll be using the 3 points. So L naught x into f naught plus L1x into f1 plus L2x into f2. But here the definitions of L0, L1, L2 will change. L0 x will be x minus x1, see it carefully, x minus x1 into x minus x2 divided by x naught minus x1 into x naught minus x2, and L1x will be x minus x naught into x minus x2 divided by x1 minus x naught into x1 minus x2, and L2x, this will be x minus x1, sorry, x minus x naught into x minus x1 divided by x1 minus x2 minus x naught into x2 minus x1. So these are the going to be the values of this L0, L1 and L2x. basically, if you try to understand it, this is nothing but the ratio of previous linear interpolation, because this is x minus x1 into x minus, if you carefully see L naught what we have defined for linear interpolation, this is x minus x1 upon x naught minus x1. So x minus x1 upon x naught minus x1. So if I represent it by small l, L naught x, this is this value. If you focus on this term particularly, this is L naught x. This is small l stands for the one we had got from the linear interpolation, this one, divided by, if you see this one, x minus x2 into x naught minus x2. So if you carefully see, x minus x naught, x1 minus x naught. So this value is nothing but L naught एक मिनट. This we can skip. I think इसकी जरूरत नहीं है हमें. This much is enough. Okay, fine. X minus x. So in this way, we can even write the in general LK means for higher degree as well. But before that, let me do a couple of examples. Let me take a data. Okay. Suppose we have this data f of 2 equals to 4 and f of 2.5 equals to 5.5. Okay. So suppose we wish to find out the value of f of 2.2. Okay. So we'll use this Lagrange interpolation since two data points are given. So we are going to interpolate it by using the linear polynomial. Okay. So what is our x naught here? X naught is 2 and x1 this is 2.5 and f naught that is f of 2 which is 4 and f1 it is 5.5. Okay. So see what formula we have written for the linear interpolation. It is P1 equals to L naught x F naught plus L1 x F1. So P1 L naught x into F naught plus L1 x into F1. Okay. L naught x is nothing but x minus x1 divided by x naught minus x1 into F naught plus L1 will be x minus x naught divided by x1 minus x naught into f1. We can put the values. So x minus x1 that is x minus 2.5 divided by x naught minus x1 that is 2.5 minus 2 into f naught. F naught has the value 4 plus x minus x naught this is 4.
सर फर्स्ट टर्म इसका नेगेटिव होगा 2 माइनस 2.5 आएगा.
एक मिनट x नॉट माइनस x1 है ठीक है ये हो जाएगा आपका 2 माइनस 2.5 ठीक है इंटू 4 plus x minus x naught that is x minus 2 divided by x1 minus x naught that is 2.5 minus 2 into f1. f1 की वैल्यू कितनी है 5.5. ओके सो इसको आप सॉल्व करेंगे तो इट विल कम आउट टू बी एक मिनट मैं कैलकुलेशन वेरीफाई कर लेता हूँ. ओके ठीक है x minus 2.5 into 4 divided by 0.5 with negative sign plus 5.5 divided by 0.5 into x minus 2.
मैं उसको देख रहा हूँ ये क्लास में करवा के आ रहा है.
Sorry? Okay, so this will be minus 2 into 4 that is minus 8 into x minus 2.5 plus 11 x minus 2. So ultimately if you solve it, it will come out 3x minus 2. So basically if I show you, So we had 2 points this. Two comma 4. And another point was 2.5 comma 5.5. Comma 5.5. Okay, these are 2 points. This one. Okay, and what we have got? We have got y equals to 3x minus 2. 3x minus 2. So you see, after using this method, what we got? We got a linear equation which passes through these 2 points. Okay, linear equation passes through these 2 points. Now we can use this method to get the value of f at any point between these two. So you can use, because we needed f of 2.2, so you can pass this sorry, p1 of 2.2. So this p1 of 2.2 will come out your 4.6. Okay, so in this way, this interpolating polynomial will help us to get the unknown values of f at unknown points. Okay, so and in this way we use that quadratic method. Then what will happen? It will develop a curve which will pass through all those given points, and once it will pass through all those given points, and it will return you a polynomial equation as well, second degree polynomial equation. So you can get the value of f at different points. Okay, so second degree polynomial का जो example है वो मैं एक लिखता हूं, आप इसे करके लाइएगा. एंड देन अगले लेक्चर में मैं खुद करूंगा इसको, बट आप इसको सेकंड डिग्री पॉलिनोमियल का जो इंटरपोलेटिंग पॉलिनोमियल है वो करके लाइएगा. ओके, इसमें एक पॉइंट और मैं ऐड कर देता हूं, दैट वुड बी एनफ. एग्जांपल, find the value of f of 0, f of 1.5 from using Lagrange interpolation for this data. F of 0, f of 1 equals to say 4, and f of 2.0 it is say 6, and f of 3.5 it is say 2. So आपको एक P2X डेवलप करना है. यहाँ पे we need to get this second degree quadratic polynomial using Lagrange method, and once it is with us, then we can have the value of f of 1.5. ये आप करके लाइएगा. Then I'll do this example as well, and then we will talk about the errors, how we can see how much error we are getting, and we can compare which method is giving higher error and lesser error. Okay, ठीक है, बताइए क्या पूछना चाहते हैं अभी.
वाला यूज करूं 3 पॉइंट्स पे और वो तीनों स्ट्रेट लाइन में हैं, तो फिर सेकंड डिग्री में मिलेगा?
नहीं, फिर आपका जो फॉर्मूला है वो कैंसिल आउट हो गए. although you will have 3 points, but वो कैंसिल हो गए लीनियर इक्वेशन ही बन जाएगा. मीन्स
Okay.
आपको अगर 3 डेटा पॉइंट गिवन है एंड यू आर यूजिंग द क्वाड्रेटिक पॉलिनोमियल मेथड, तो इन जनरल यू कैन एक्सपेक्ट यू विल गिव अ सेकंड डिग्री पॉलिनोमियल. बट अगर आप एक कोलिनियर डेटा लेते हो तो उसमें क्या है कि यू कैन यूज दैट पर्टिकुलर फॉर्मूला फॉर सेकंड डिग्री पॉलिनोमियल, but it will cancel out and it will ultimately give you a linear polynomial. Okay?
Okay, sir.
ठीक है, नेक्स्ट लेक्चर में मिलते हैं.